I hope my promotion at the booth played well. So this is some food. By the way, that's the food I ate here in Barcelona a couple of years ago. So it's not AI-generated picture, a real one, a real stuff. And it is good quality food. But some years ago, many years ago, me and my future wife, we decided to arrange a small party. But the party was after a long winter holidays. So we went and bought a cake. Just we wanted something sweet, some dessert. Oh, the party was good, and the cake probably, I don't remember. It was good, and I ate most of it. And it turned out that the winter holidays were too long, and nobody really cared about the ingredients of the cake. So the next week was a disaster for me. I still remember it after many years. Maybe that was a rotten egg or a different rotten thing that you couldn't feel while you eat cake, but afterwards it struck back badly. So we'll try to discuss some aspects of building and propagating artifacts, images that will, or I hope they can prevent such things from happening to your code, well, and to you in production. Sometimes I cook myself. Oh, well, I just cook. But that might be considered only a hobby. The things that I do at my work are related to OpenJDK development, and the company releases a well-known distribution, and yeah, the BellSoft is a member of some distinguished communities, and releases its own distribution, which is a recommended distribution for Spring called Liberica JDK. You probably know of it. You probably know it, and our distribution of GraalVM native image called Native Image Kit, and Linux distribution called Alpakita. Using that, using all the artifacts for JDKs and using our own Linux, we also deliver container images based on that Linux, including now hardened images, BellSoft hardened images, which I'll mention today in the context of using some advantages that they give. I won't dive in big details about it that deserve a separate talk, but I'll explain some concepts behind that. Here is the questionnaire. If you go to our booth, there are still such leaflets. So check yourself, or you can check yourself right now. There are some questions about your treatment of vulnerabilities, of some information important for security. Right? What do you do? How do you update your images? What's the policy, or what's the practice in your company? And surprisingly, I see, so I was here yesterday, so it's a quite popular one. So anyone who takes the questionnaire starts hesitating and analyzing and maybe estimating himself or herself. So think about it. And we'll get back to it slightly later, just in a few slides. But rate yourself or your colleagues. Say, hey, they probably don't do enough. Well, what is this chart about? Any? What?
Number of vulnerabilities.
Number of vulnerabilities. Okay. that counts. That's fine. Any other suggestions? Searches for AI. Nice. Not too related to today's topic. What else?
Number of artifacts used.
What?
Number of artifacts or packages.
Number of artifacts and packages, yes. It also grows. Number of malicious packages, yes. What else? Basically anything else that's related to the topic. It grows, and it grows rapidly, like it's sketched here. So the number of artifacts existing, the number of artifacts being downloaded, the number of vulnerabilities discovered, the percentage of vulnerable versions of some artifact, or presence of vulnerable versions, etc. That's all growing. And that means we multiply all the numbers and we even get a worse picture, and that means growing risks. So we obviously have risks of being, well, hacked in production, right? Because if you run a vulnerable component, that means it is open to some attack, which may be exploited. Well, and at least it would be great to know about it, right, that it happened. But the best would be to prevent it, to get rid of it by somehow. Or to realize, okay, we actually are not vulnerable. That may also be the case. So along all that danger, right, there are multiple different parts in it. If we write source code or take someone's source code, it may contain poisonous ingredients in the source. Who remember the last famous case last year? Just 2 letters, XZ, right? The source code was poisoned because the developer's environment was compromised. Well, probably not related to today's topic, but still some part of it probably may be defended by good techniques. Build pipelines, right? If someone breaks into a provider that delivers some platform solutions or important infrastructure, binaries like scanners, that may go wrong. Who remembers the last example? Trivi, right? The scanner that we love, but now they got some experience. Well, dependencies and container images. We may pull some dependencies, and even pulling them, again, getting back to the last example, may be dangerous if they are some unknown ones and the installation requires some custom code. And of course, using some unknown things from unknown suppliers with unknown functionality just to calculate the checksum of a string, probably that's not a good idea. And container images that we consume somewhere, right? They may be tampered. Because it's a thing we get remotely or it's stored somewhere, and all that somewhere may be compromised. But who do we trust? We'll talk about that a bit later. So that are the central parts that probably related to today's topic, right? To SBOMs. Container registries, they can be compromised themselves, just like the CI infrastructure, right? Someone may replace the image on its way or right where it is stored. It's technically possible. And deployment, if any other way exists where some random image can be deployed to your production, you have a problem, obviously. So here's the scope, right? And so what do we do with that? There's no single-time solution. We must do it continuously. Well, actually, care about security. So that's the foundation of DevSecOps practices, right? And here we are, I think, mostly devs, right? But having it in a single word means we must be a part of it. Anyone heard of it? The CRA? It's a big word now here in Europe. And in different countries, there are different similar regulations, more or less similar, related to the topic of the talk. And the topic of the talk is software bill of materials, SBOMs. Who have heard of SBOMs? All right, the minority of the audience. But I won't explain it in detail. So briefly, it's a document describing the ingredients of what you have in the cake. And it should say, hey, we actually have an egg, and the egg has been collected from a hen some few weeks ago, and it wasn't properly stored, and there are some other things. And you may consult to the supplier, or you may consult the egg supplier, and they say, hey, this egg is definitely rotten. We actually have its number. It's tracked. Just no one told you. Don't eat it. I already did. Bad for you. So, not being a lawyer here, but this document sometimes obligates you to use SBOMs for your software, even internally. Not always publish it, but to have it, to use it, to keep track of the components that are contained in your software, third-party components that someone brought to you. So you take the code, and most of the code being used by some statistics is the open source, taken from somewhere. Well, so that's an important one. And here we go to the analysis of our naughty behavior with images updates. That actually can be mapped, at least in my mind, to the software maturity model. So if you answer those questions, you rate yourself somewhere between 1 and 5. Right? So sometimes it's counted from 0, because level 0 is not doing nothing, but doing close to nothing. And on those levels, there are certain things we should, well, certain practices we should apply, or it is better to apply, to be rated higher than before. And to be rated higher in terms of security means being more secure, right? Having less risks, preventing your production from being hacked, crashed, from downtimes, from incorrect behavior, all of that. And yeah, from preventing it from losing users' data, personal data, any details, all that is important. So initially, at level first, you think about what to do. So you select tools, you work out a plan, right? So you analyze what will happen on next levels. Maybe you just realized the problem. You've got some report, accidental report of scanning, or you figured out that scanners actually exist. And you think, oh, maybe we should try it. And on level 2, you start trying that, right? Maybe it's some advanced technical lead who just runs some scans and tells the team, hey, you just delivered, what you have just delivered, what you have delivered last week it actually contains those vulnerabilities. We have new work now, right, to update it, to fix things. And when you analyze your components, you start thinking, maybe we should track it somewhere, just to write down those incidents, write down what we have found, and what we have done with those findings, right? And at next level, defined level, you go to regular scans. You see, hey, we actually must scan our stuff regularly. We must be aware, at least, I don't know, once a week it will be true, and up-to-date information, what happens with different vulnerabilities, different non-security problems that are there in our software. Right? It may be a bit outdated, but not too old. And we know that, okay, next Monday or some other day, it will be available. At next level, all that information is not just known, it's being formally managed, right? So newly discovered exploitable vulnerabilities related to what you build and run they derive some tasks, they derive some actual work items, to-dos, issues, to fix that, and that workflow triggers certain processes, and all that being discovered continuously. And that probably corresponds to all the check marks in the questionnaire. And at level 5, you actually try to fulfill, or you say, we do fulfill all the SLAs, defined SLAs for the software security and reaction to different incidents. And there are certain KPIs for certain roles, and that KPIs are being fulfilled as well. So that's the ideal world we can imagine. Nobody lives in it, or at least I don't know such companies. But really, all those practices do exist and being used. And that, the deeper you go in the stack, right, the more effort it takes. But the effort goes finally, right, to some platform organization. So it's not obviously a task of a Java developer to build all that entire process ecosystem, right? But you have to spend your time negotiating with it. But someone else should build it for you. It's good to say so. So getting back to SBOMs, right? What do they actually do, and how do they look like? We'll maybe see a tiny piece of SBOM in a few slides. But basically, it's just a JSON file. Even worse, it can be a JSON decoded as base64. Because we like to send and receive documents via curl, right? Or simply via HTTP requests. And that's why we need base64. And also that makes it look cryptic and cool. So no one, not being a software engineer, understands, hey, it's actually base64, and I can even decode it. There are two popular formats, CycloneDX and SPDX. CycloneDX is actively developed in Cloud Native Computing Foundation, and CycloneDX is used, maybe originated in Linux kernel community. They develop in a bit different directions, and some tools better work with one format, some tools better work with a different format, and they let you do slightly different things more easily. But for the purpose of describing artifacts in a Spring Boot application, they are more or less interchangeable. And in fact, there may be different bill of materials. For example, there may be a hardware bill of materials, right? What hardware is used for your production? Describe it write a JSON file, and maintain it. And that's important information, right? It may be a runtime SBOM. So what happens with your software in runtime? What files does it open, or what network connections it does, etc. So that's important information. What's being done, in fact, in your runtime, right? That's not the same as what happens or what is known during compile time or image build time. The deployed SBOM, right? What is deployed? Simply describing what you've done in deployment. Analyzed, design, nothing, no one uses that. And there's a cybersecurity organization, CISA, that actually invented this classification. But anyway, it's convenient, right? And different SBOM formats, they more or less follow this classification, so they allow just a field that says, hey, this is a document of some type. But we won't talk only about SBOMs. It's a matter of trust. So you trust someone, but verify. You trust and you also verify. During turning your code into some deployable artifacts, making your code run in production, it is important to verify the very strong statement that in production you run the code that is known to you. The exactly code, the same code that you can point by location somewhere in the source repositories. It is hard to do, so you use basically two things here. First, you use some signatures, right? So cryptographically strong statements you can easily check, but that are hard to falsify. And the second important assumption here is that the chain, the infrastructure, is not compromised. So you have properly signed and no one has stolen your key and made bad things for you, right? Because currently you can't verify what compiler does, right? There's one great thing that you can do. For example, what we do as a software vendor, as a provider, is a reproducible build. So you can give your customers all the bits about how artifacts were built. They don't have to rebuild it themselves, because otherwise, why would they need you, right? It's more convenient to use you. But they always can verify and repeat and get the same result. Bit by bit, say, OK, that's probably the right way, and the supplier is not compromised, right? We never may know. It still can happen by somehow or a different time, but it gives you some assurance. So finally, let's meet the SBOM. And let's do it using Spring Boot, of course. Simply compile your application and read the compilation log. Well, right? Say, maybe install, and look what it prints in there. And in the end, it actually says, hey, here's the SBOM. And it also gives a hint about the format of the SBOM. What's the format here? CycloneDX, yeah, CDX. So this SBOM is placed into the Artifactory, right? In the main repository. It is also placed, well, in your target folder, and it's placed in the resulting jar file, if you assemble the fed jar file. It's very convenient. And even beyond that, that SBOM is available online. So by default, that SBOM is exposed as an endpoint, so you can access it from different services or from some internal service that collects SBOMs and analyzes them. And by default, the application won't start if it's not exposed, if it's not there. It will ask you, hey, probably something is wrong. You don't have an SBOM. Maybe I'm a malicious one. Won't hurt you, won't start. So what should we do with that SBOM? Right? We can go and check it. Right, to go to that endpoint, say actuator, SBOM, application, and here's the SBOM file. There may be multiple SBOM files, right? It's not a problem. You shouldn't try to build the only and unified one of different pieces of information you have. Sometimes that may be convenient, but using and keeping different ones, even in different places as we see it later, it is actually convenient. It can help you to understand and keep track of the origins of those source bits. So you see here the format, the spec version, right? And later, which is not the part which is not visible, is a long list of different artifacts, libraries included, right, with your application, all your dependent jars being presented as a flat list. In that flat list, there may be dependencies, of course. That's an important information, where dependency comes from, so you can reconstruct the dependency tree or dependency graph afterwards. And there are package URLs, which probably are not visible here, but that's an important thing. So, well, this is the SBOM, right? We have built it, and it says, hey, this cake contains a perfectly good egg. Something is wrong, right? At the kitchen, they wrote an SBOM file telling, this cake contains egg, and this egg is fine. Because they haven't verified it. So you have to verify that the artifact you include in your application is not a fake one. How would you do it? Well, first of all, the HTTP without TLS is prohibited. So you trust the connection between you and, for example, Maven Central. But sometimes it's not Maven Central, right? It may be a cached local or organization internal repository or something else. Or maybe you have to deal with some man in the middle because you decrypt and encrypt traffic again. So you can trust only the checksum. Someone might replace the checksum for you. You see it, but it's wrong, and it's a malicious artifact. So what would you do? And actually, you can check the signature. The artifacts can be, they are supplied with signatures. They are signed. We just don't check it. We blindly use artifacts without checking signatures. So it's not the default behavior. You can use plugins for that. You can actually do it in a simple, shell scripting. Just take the list of artifacts and check the PGP using the regular PGP tools. And just the same as we trust TLS certificates, trusting by the who? Certificate authorities, which we have as trusted roots in our system, in Java or in the operating system or even in hardware, right? We have special keys from some organizations from which we can derive a key chain to build some trust. And here we should trust that key, right? That fingerprint, etc. We somewhere get it and say, okay, we know those guys. Those numbers are telling us true. That's the cornerstone of trust here. Well, I think that all should work fine. So we have checked the origin of the artifacts. And we constructed the description of all the artifacts we have. That's good. So let's finally use some convenient tools. Not simply looking at backcode, but analyzing that graphically, and there are plenty of them. For every format, there are different viewers, but of course, let's prefer the open source ones. The ones we can verify, run, and put some data there. Because the data about the set of components we use to build our software may be quite sensitive sometimes. So, yeah, and by the way, there are two SBOMs. One SBOM, no, probably it's beyond that. First one, is generated simply by the Maven plugin that derives the SBOM from Maven dependencies, taking that information. And another one is derived by a scanner. So this is the scanner I prefer at the time. Do you know why? OSV scanner. Well, because at the time Tree is at risk, or was at risk. And also because OSV scanner is a community effort now. It's a Google project, but they accept pull requests. And it already supports Alpaketa Linux. So it's able to scan Alpaketa Linux, produce some meaningful results that can be used later. And it also supports Spring Boot, of course. So we take the fetcher and we scan it, right? Or we scan an SBOM that's derived by a different scanner, in this case, SIFT. And you see the results are different. Some information is lost from a perspective of the later tool. So the numbers of packages are not the same. And it's quite visible here. So these are all dependencies, right? Presented as that sun rays. And on the left, there are much more details than on the right. So this one was not constructed from the original information, but it was constructed by scanning the artifact, the final artifact. So by scanning, you probably lose some information. Well, there are ways to help it. All the data can be enriched by AI, for example. We can take the original SBOM and wisely add some bits of information on top of that. So the tools that work more straightforward would be satisfied. Well, we have it. And we can, for example, scan different versions of Spring Boot Pet Clinic. So I took version 2.7, which I know contains some nasty vulnerabilities. Version 3.3, I think, and a current version, which is 4 snapshot. And you see the number of vulnerabilities, known vulnerabilities, reported by scanners. That's CVEs, right? That's a vulnerability whose information has been disclosed. That's a known one. And a vulnerability is related to some software components, right, which we can identify and relate to what we have in our SBOMs. That's the good thing in all that process of having SBOMs. The number of vulnerabilities in all the releases, which we don't update, continue growing. Because, well, what else can happen? They are being discovered, and if you don't patch it, you become more and more vulnerable for sure. Right? It's the same code, but more people and tools know about problems in that code. And current release is pretty good, right? Well, one critical. Who knew about it? So let's get to images, right? Let's verify and scan base image Because we built our application image from what? From a base image and the application. Well, sometimes we build it from 3 components, right? We take some image, take some JDK or whatever, the other software. The key point here, there is a base image somewhere. And we must ensure that it is not fake, right? We must know what is inside to be able to react to some threats to that components. Well, why don't we start from OpenJDK here? Who uses OpenJDK image? My favorite question. From OpenJDK, don't be shy. EA, yeah, that's what I like. The official image that officially says on its page, hey, I'm deprecated, don't use me. And people still continue using it. And they have removed release tags, trying to make it harder to use the image. But people still just simply add EA, -EA, and continue using necessary Java versions. Please don't do that. OK, we'll take another image. We'll take Tamarind. I'll try to do what? To check its signature, just as with Maven artifacts. Let's check the signature of this artifact, of the base image. Is it signed by a proper authority or not? Well, there's standard Docker way to do it, but it says, well, nothing. But actually, there are some signed tags. But that's not the only way of signing. So you're not obligated to use this Docker trust signing. So for example, if you inspect our hardened image, right, the image that should be secure because it doesn't have the package manager and it is aimed to bring 0 CVs as a base image, as its best. And it doesn't have that signature. But it actually contains, oh, do we have internet here? Sorry, I lost the signal. But we'll try to recap with a slightly different one. It's Google Slides as we like them. Oops. I'll share the PDF, right? Huh. Oh. Here we go. Sorry for that. So we go with an image, and we can use cosign, another great tool that helps us to sign and verify signatures of different stuff, binary artifacts, but also container images that are essentially also binary artifacts, right? There's some compressed folders with some metadata. But we can take a public key, a thing that we trust, and verify it against the public key. There is also a mechanism for keyless verification. So without having a valid key at the time. So if you don't have a very important secret key, it can't be stolen from you. If you only use temporary key for signing, there's a mechanism for that, but we won't focus on that. So, and yeah, here, many letters here, right? Because we have done it in the right way. So we've pinned to the hash, because the same tag name actually can drift along hashes. So we stick to the same hash. So we will be sure which version do we use. And we can get the signature check, and we can extract the SBOM from that image. So we take the hardened image. Oh, here is the base image, but anyway, it's the same works for Liberica runtime container hardened image. We just say, hey, please, cosign, verify attestation, verify the statement that this image actually has this set of components written in this SBOM file. And it extracts that information from a special part of the OCI image storage. And we can decode it from base 64, and we can analyze it with command line JSON tools, so we can load it in Python or use special libraries or whatever to work with that JSON, right, to our own needs. Well, finally, let's take that SBOM and let's scan it. Let's take our precious OSV scanner, right? And it says, hey, no issues found. And that scanner supports the image. Great. So that's how zero CVs look like in command line. And let's compare it to Alpine, for example. And even OSV scanner has a nice mode of creating an HTML report for you, right? It can be used online somewhere. Go to the web page and see all the vulnerabilities. Oh, and that's the latest tech. Have you heard of it? Like, you can see some red bricks. So we have created an online comparison. If you go to the hardened images page on our website, we just let you to compare scanning results in kind of happening daily or even more frequently for multiple different images, so you can compare. Yeah. So we have verified the base image. We have verified our libraries for our application, and we trust our code because it comes from our non-compromised CI and source repository. So let's combine the resulting application image and let others verify that it is a right one. So we build the image and we sign it, and we optionally can also put SBOM in that, right? And we scan it to verify ourselves that it works right. So let's take some simple image. It doesn't have Java options and other things that I do like. But it originates from some hash. And we again take our key, in this case it's also a signing with a key. And we take our private key, which we show no one, and we give everyone our public key for verification. So it works. So we have that provenance part here in the image. But what about build packs? We don't have Docker files, but the process is more or less the same, except what about controlling the base image? How would we check it? Well, we should check the base image ourselves, and in case of hardened images, we should take special build packs, which we have created. So we provide hardened images by default, and maybe that's the only option now, as for your build stack and for your run stack as the basement. So you have that low CV images as base images for the entire build pack process. So we only plug in our build packs and you say, hey, build an image. And you can scan the resulting image with OSV scanner, right? It will scan both components, system components in the image, deriving from the base image. It will scan the application, and you see, no issues found. To compare, let's base another image on Alpine. Oh, not on Alpine. Let's take the default build pack, which is also good, but it contains more components, so it's frequently a case to see more vulnerabilities there. It doesn't mean it's bad. They are being fixed, they are being addressed. But typically the number at the time is higher. So that's the result of OSV scanner. Again, that's how security looks in real in the command line. Right? Nice table. I would like to program one. So what happens in CI/CD? What do we finally do with those SBOMs? Well, it's a textual information. We can process it. We can run scanners on our images. We can actually work with the JSON contents. So we can consume the image, right? We can extract it from, we can consume SBOM from an image, and we can do anything we want. The major point here is, what do we produce? We let the image go. We add extra artifacts. We stop it from going further, saying, hey, like, I've grabbed the SBOM contents, and it contains the word GPL. No way. For example, or it contains log4shell, log4j. It's scary because of log4shell. Now go. Things like that. Quite easy, right? We just write workflows, and we execute some code there, probably using other containerized tools or whatever. But we do the same. We extract the SBOM information as JSON and process it. And also, we may want, as if we are on higher maturity levels or deeper maturity levels. It depends on how you look at it. We may also keep that SBOM information in a special place called a SCA system, Software Composition Analysis System. And there are existing ones, and I'll name dependency track here. And you can upload your SBOMs there, and you can consume from there, and you can automate all the things that happen in your system. And there are plugins that help you to integrate that information into your workflows, into your GitHub Actions, right, or into your GitLab workflows. Just reuse the plugins and do the same stuff. Just don't write it by your own. If we go beyond that, we say, hey, we need some sophisticated decisions, but we don't want to script it in JQ and shell and whatever. Or we don't want to depend on Python libraries that break. There's a solution. One notable thing here is Rego. Probably it's requirements Go, but I don't know for sure. At least I decrypt it like so. So it's a language that lets you describe in an object way predicates, actually some small programs that return true or false, right, about your SBOM files. And you embed that, again, using special libraries for your CI to make decisions during your workflows. Well, in Kubernetes, it's quite similar, right? You can also use such policies as a code, or you may write some custom your own bits, just executing some processing. So, for example, you may create a service that runs as a cron that consumes different SBOMs and puts them somewhere in a volume, right? So Kubernetes looks like a computer for you, a Kubernetes cluster. But that's not too mature, but it's much better than nothing. Again, you can use a system to store your SBOM information, some other information, and use plugins to work with it. And important tasks here are gatekeepers or webhooks to stop improper software components from running in your Kubernetes cluster. So you say, no, we're going to provision a pod, and it will have that license. We won't do it. Or it contains critical vulnerabilities. Or the number of critical vulnerabilities are too high to deploy another one. Because you may say, oh, well, 10 is OK, or like, small percentage is fine. And finally, someone still analyzes all that SBOMs. Security guys, not here in this room, but they do it continuously. So they repeat and repeat the process. So you must reduce the scope as a responsible developer, or we must reduce the scope as a responsible vendor. Well, we don't have it right now. So what to do here? How to help to reduce the number of actions we take daily to relate the newly discovered vulnerabilities, that are present in our software, and to stop infinite deployments and redeployments and all that. Well, actually, someone can analyze the major part for you, right? If big top components are actually vulnerable and that vulnerabilities are exploitable in certain circumstances. That is important information that can help to reduce the amount of work or can help to get rid of it, right? And say you don't need to update. You actually don't use the software in the mode where it's exploitable. And it can be written in a formal JSON document called vex that can be, again, semi-automatically used in your processes to help your software secure. And that's how it probably will look like in the end. Many different acronyms, but we don't care as developers, right? All that static analysis, dynamic analysis, that's being done for us by platform. But it's good to have those. So please try hardened images because they have signatures. Verify that signatures. Study our SBOMs. I know they're imperfect. Please report the usages and build your own ones. Right? Run scanners, build secure images. Stay safe. Thank you. We still have 1 minute for questions.
Yeah, I do have a question.
Great.
So you said we should check the signature with the public key, right?
Yeah, the question is, we should check the signature with the public key.
And this public key is where?
Is where? But the public key is distributed publicly.
So how can I be sure that this public key that I take
how would you trust the public
is
key?
not compromised? Yeah.
That's the chain of trust you should build somehow. But sometimes it can be kind of keyless check, but still you need some chain of trust. Imperfect world. Yeah. All right. Thanks again. I'll be around. See you here at the booth at the conference. Thanks for coming.